Okay, so now we're going to talk about, in this section 3.5, transformations of functions. So there's different ways we can take a basic function and we can move it or we can change the shape of it, and those are called transformations. And there's a few different kinds. We're going to start with what's called a vertical shift. So think back to those basic functions we did. Sometimes we're going to use those and we're going to perform transformations on those basic functions. Sometimes they're going to give us a different function. Okay, but it's all having to do with how the graph changes. All right. So in a vertical transformation, what happens is you have a function, a new function, call it g of x, and it's equal to some function plus k. So let's say you have a function that looks like that. Okay? I don't know, just pretend that that's the function. Well then, what you're doing is you're taking all the outputs and you're adding some number to them. So let's say you had, call this f of x, and let's say g of x then, just a minute, I'm going to change this, color coordinated. Say g of x is equal to f of x plus 2. So what that means is every output is going to move up 2 units. And so the whole graph gets shifted up 2 units. Okay? That's the idea of a vertical shift. Okay, so if k is greater than 0, then you're going to have a shift up. A vertical shift up. If k is less than 0, meaning it's negative, you're going to have a vertical shift down. Okay? Alright, so that's what a vertical shift looks like, and that's what it does. So here's an example. To regulate temperature in a green building, airflow vents near the roof open and close throughout the day. The graph shows the area of open vents, V, in square feet throughout the day in hours after midnight T. Okay, so many hours after midnight, this is the area of the vents, okay, that are open. During the summer, the facilities manager decides to try to better regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and night. Sketch a graph of this new function. So what we're going to do is our new function, I don't have a name for it, n for new, is going to be equal to v, the old function, plus 20. We're going to increase all of them by 20 square feet. Okay, so what happens is my new graph is going to just shift up. It's going to shift up 20 square feet. Now, the measurement for square feet's over here. So at 0 time after midnight, it's going to go up 20 square feet. I don't know, like maybe right there. And then that's going to keep happening until 8. So the shape's going to stay the same. But then this point right here, that's going to move up 20. So it's going to be probably like about there. And then same thing here. So then my shape's going to go from there to there. And then down here, it's going to go like right there. That's going to move up 20. And then that's going to move up 20, so it's going to go... I'm not drawing very good. Probably a ruler would help. But okay, the whole thing should look like it shifted up 20 feet. It's like you just picked up the graph and moved it up 20 feet. Square feet, sorry, 20 square feet. All right, that's a vertical shift. My graph doesn't look good, but there's pictures in the book. That'll help.